Hi, I'm Dr. Keith Porter, Chief Engineer for the Institute for Catastrophic Loss Reduction. I'm at our Resilience Display Center in London, Ontario. This display shows how to reduce earthquake risk to older wood frame buildings. The display shows an older wood frame house. This is the first floor here, and this is the foundation there. We sometimes call this little wall between the foundation and the first floor the cripple wall. Now that wall is fine for resisting the vertical force of gravity, but before the 1990s or so, cripple walls tended to lack lateral or side-to-side strength, and that's a problem in earthquakes because the ground suddenly moves from side to side in an earthquake. The cripple wall has to be strong enough to drag the house back and forth when the ground moves. If it isn't, the ground suddenly moves laterally, and the house, being an object at rest, wants to stay at rest. So it stays in the same place when the foundation suddenly shifts to the side, like that. And the cripple wall collapses. When that happens, the damage can cost more to repair than the house is worth. That's a total loss right there. We can prevent that from happening by nailing structural sheathing, that is to say plywood or oriented strand board, to the inside of the cripple wall, that little crawl space between the foundation and the first floor. When I flip up these little panels here, that represents nailing structural sheathing to the cripple wall. Now, if the earthquake comes along and tries to move the foundation side to side, the wall is strong enough to drag the house with it and the wall doesn't collapse. Now, before about the 1970s or so, the problem was a little bit worse. The foundation tended, the first floor, this wood part of the cripple wall, tended not to be positively connected to the foundation. It was just set in wet concrete, and over time the bond between the concrete and the wood can deteriorate and lose strength. And when that happens, and an earthquake comes along, and the house simply slides off of its foundation, and that can be a total loss right there. And of course, before if you've got both problems, unbraced cripple wall, which tended to be before the 1990s, and lack of foundation bolts, then both things can happen, and it's much more likely that the house will be a total loss. Now we can prevent both those things from happening by adding these, by bracing the cripple wall and adding foundation bolts. Now we can bolt the house to its foundation by adding bolts between the sill plate, that's this little piece of wood there, and the foundation, or we can add a metal plate to the inside or the outside that connects the foundation here to the sill plate there. Either way, that adds positive connection between the foundation and the sill plate, and now the house can't move from side to side. Together, those retrofits can cost about $5 a square foot, or about $10,000 for an average sized house. The U.S. Federal Emergency Management Agency, FEMA, offers a free publication called FEMA P1100 that has drawings and specifications that you can just hand to a construction contractor so that they know exactly what to do to add these bolts and the braces. That's called an earthquake brace and bolts retrofit. And you don't need an engineer to do any structural drawings or